In this video, I'll talk about some of the different types of organic reactions. Now, if you have looked at some of the other videos and maybe in the beginning of the organic chemistry course, you will see acid-base reactions being one of them. So acid-base reactions are indeed one of the types of organic chemical reactions you've seen, like nucleophile, electrophile, which are technically kind of the acid-base reactions as well, just in a little bit more elaborated version of those. And then you have oxidation reduction reactions as well. So those are also typically seen. But then in addition to those, you also have some other organic reactions. And I would say these 4 or 5 different types of organic reactions really make a whole bunch of total organic reactions. I would say more than 90% or 99% of the organic reactions will be made of those 5 or 6 different types of organic reactions. So the first one I want to talk about is a substitution reaction. So what you really do in a substitution reaction is where, suppose I have a compound that kind of looks like this, and then I'm using something here, and I can just write down Z here for a minute. And when I'm using this Z in here, what I'm really doing in here is replacing that Z and getting rid of that bromine as a bromide. So you still want to make sure you conserve the charges. So when you're looking at the reactant, you got a -1 net charge. Still got to have a -1 net charge on the product side as well. But the bottom line here is why we want to call it substitution reaction, because I have something attached to this molecule here, and I replaced with something else. So it's kind of we substituting with something else. So I can talk about something being like, let's say I have this reaction here, and then I'm kind of going ahead and making this right there. So I can go ahead and use water here as my reagent here and the reactant here, and then that makes this HCl. So this is also a substitution reaction because, well, I already have something attached to this molecule here, but I replace this with something else, which in this case is the OH. Now, how do I really identify the substitution reactions? Obviously, you want to look for like what you have as a starting material and what you have in the product. But one of the things that you have to have in a substitution reaction is typically you have to have a good leaving group. So in both of those cases, in both of those examples, if you look at here, I used bromine and I used chlorine that was kind of knocked out with something else. That's because both the bromine and the chlorine, they're both good leaving groups. And the halogens that starting from chlorine, bromine, and iodine, they're really good leaving groups. So you will be seeing a lot of those in the substitution reactions. Those are not the only one, but those are some of them that would be showing up a lot. Now, in addition to substitution reactions, you can also have elimination reactions where you have in a main molecule, and in the main molecules you would be losing something, and you want to kind of keep an eye on it, like what you're really losing at the end of the day. So in this case, if I'm starting out with this molecule here, let's say I'm going to go and draw a bromine here, and all of a sudden I make something like this. All right, so now I want to kind of pay my close attention here and to like what I really lost in there. And if you pay close attention, I kind of lost the bromine because that's not really there anymore. But then I also have created a double bond between those middle and the right carbon. And to do so, I must lose something else on the right carbon. Because remember, the right carbon already has 4 bonds to begin with, and I can't really make a double bond and not lose one of those hydrogens, because that would make 5 bonds otherwise on that carbon. So what do you have left at the end of the day on that right carbon is just 2 hydrogens. And that means I lost one of those hydrogens in there. And after losing that hydrogen and the bromine, I can probably just say I made an HBr on the side here. But the bottom line here is whenever you run elimination reactions, you lose something from the molecule, and you eventually create something on an alkene or alkyne, or I can say you typically create pi bonds in there. So the way you make alkenes and alkynes, so I can write down here the synthesis of alkenes and alkynes are really in a process of elimination reactions in those cases. Now, what's really an addition reaction? So addition reaction is literally the opposite of elimination reaction. So I can have a molecule that actually has an pi bond that includes the alkene. So suppose I have this alkene here, and suppose I'm going to go ahead and add something to it. So as the name specifies, I must be adding something to it. So when I go ahead and add an HCl to it, I will end up making something like this. So where I get chlorine hooked up right there. And what I want to do, I want to kind of go back here and write down all the hydrogens, especially on those double bonded carbons, so you can see what's being added in there. So remember, I already has an hydrogen there. I had two hydrogens here, and I had two hydrogens here. And then one of those hydrogens will also be getting added to that carbon there. So that way, this hydrogen and that chlorine were added onto this pi bonded carbons, and that's what makes it an addition reaction. Now, the question might have been like why I put the chlorine in the middle one and not in the side one. So the idea is I could technically go ahead and add in the chlorine here and then add in the hydrogen here that was coming from the HCl. All right, so this HCl, Cl here, hydrogen there, or I could have the H added to the middle carbon and the chlorine added to the terminal carbon. So which one of those are really going to be the possibility? That's something you'll learn down the line, but right now you just want to be able to identify what's really an addition reaction, what's really an elimination reaction, and what's really the substitution reactions that you have, and be able to identify those. And if I want to talk about like you don't only have the alkenes, but the alkynes also undergo a lot of addition reactions. So you don't have to have only HCl. I could use some other reagents as well that gets added onto those double bonded carbon atoms here, and that ended up making an addition product at the end of the day. I could very well have an H2 as well. Like suppose I just run in a reduction here, which is just an H2. And what that H2 does, it adds the carbons or hydrogens onto those double bonded carbons, and that's pretty much it. Now, I do want to mention one thing that, okay, I know I'm adding in a hydrogen here and I'm adding in a hydrogen here, but then always remember that you don't have to necessarily show the hydrogens. So the product for that one would have been just an alkane here. And in the previous case, I could also show this as just in the three carbons in the chain, and I will draw the chlorine. I do not have to necessarily draw this hydrogen that was on the right carbon, because remember, we don't show the hydrogens on the carbon skeletons here. And I can say something similar about the right structure here, where I can go ahead and draw it as with the chlorine connected to the right carbon, and that's pretty much it. So you want to be familiar with how are there are going to be different ways of drawing these things, but they really mean the same stuff at the end of the day.